Skeletal muscle. We will learn from light microscopic structure, ultrastructure, and contraction mechanism. Here, we should distinguish some terms. The external sheath of dense connective tissue surrounding the entire muscle is termed epimysium. The connective tissue around each bundle of muscle fibers is called perimysium. A delicate layer of connective tissue is called endomysium, consists of basolaminar and reticular fibers. Between the sarcolemma and the basolaminar are located muscle satellite cells, which can proliferate and differentiate muscle fibers. So, muscle satellite cells can repair injured skeletal muscles. Light microscopic structure. Muscle fibers are long cylindrical fibers with very few branches, numerous nuclei. Muscle fiber is between 1 to 40 millimeters long and 10 to 100 micrometers in diameter. The nuclei are located in the cytoplasm beneath the sarcolemma. The sarcoplasm is filled with myofibrils. The muscle fiber shows cross striations of alternating light and dark bands. This is the light micrograph. Upper is transverse section, lower is longitudinal section. Myofibril. Myofibrils fill in the sarcoplasm. They contribute to the formation of cross striations. They have A bands, I bands, H bands, M lines, and Z lines. Dark band is termed A band. Light band is termed I band. A pale thin H band bisects the A band. A very fine dark stripe termed M line is present in the middle of the H band. I band is intersected by a thin dark line, the Z line. Sarcomere. The sarcomere is a segment of the myofibril between two adjacent Z lines. It is the basic contractile unit of striated muscles. Ultrastructure includes myofibril, transverse tubule, and sarcoplasmic reticulum. Myofibril. Myofibril consists of bundles of thread-like elements termed myofilaments, including thick filaments and thin filaments. Thick filament is composed of myosins, which have two heads, also termed cross-bridge, and one rod, occur in the place of A-band central portion of sarcomere. Thin filament is composed of actin, tropomyosin, and troponin, present in I-band and extend for some distance into the A-band, 1 micrometer in length and 5 nanometers in diameter. These are thick filaments and thin filaments. Thick filaments and thin filaments are arranged in regular pattern to form sarcomere. Transverse tubule. It consists of numerous tubular invaginations of the plasma membrane. Each one is called a T-tubule. Function: rapidly conduct impulses for contraction to each myofibrils. Transverse tubules form a complex of a nestomycin network of tubules which encircles both A-I junction of each sarcomere in every myofibril. Sarcoplasmic reticulum. It is a specific smooth endoplasmic reticulum and form a series of networks around the myofibrils. longitudinal tubules join each other in the region of H band to form fenestrated net. At the junction between A and I bands, they forms the terminal cisternae. The complex of T tubule and two adjacent terminal cisternae is called a triad. The circle indicates a triad. Function: sarcoplasmic reticulum is rich in calcium bond and specifically regulates the flow of calcium ions necessary for rapid contraction and relaxation cycles. Contraction mechanism of skeletal muscle fiber. Sliding filament hypothesis has received the most widespread acceptance. Contraction cycle. Neural impulse is conducted through myoneural junction to sarcolemma. Then the impulse is conducted inward by T tubules, triad to sarcoplasmic reticulum. Calcium ions are released to the sarcoplasm and bound to troponin. Spatial configuration of thin filaments is changed. Cross-bridge of myosin bands with actin. ATP is slipped into ADP and phosphoric acid, and the energy is released. With the energy, the cross-bridge pulls the actin past the myosin filament. The result is that the thin filament is drawn farther into the A band, each sarcomere becoming shortened. After contraction, calcium ions are pumped into sarcoplasmic reticulum. Relaxation occurs. In contracted state, I band is shortened, A band is not changed.